Basic electricity, understanding the fundamental principles of electrical phenomena, including voltage, current, and resistance. Electronic circuits, exploring the design and analysis of circuits involving active and passive electronic components. Electrical components, examining various components such as resistors, capacitors, and inductors, and their roles in electronic circuits. Electrical engineering, delving into the broad field of electrical engineering, covering power systems, control systems, and electronics. Radio wave theory, investigating the principles behind the generation, propagation, and modulation of radio waves. Wireless communication, studying communication systems that transmit information without the use of physical connections, including mobile and satellite communication. Electromagnetics, exploring the relationship between electric and magnetic fields and their impact on electronic systems. Electrical measurement devices, understanding devices used to measure electrical quantities, such as multimeters and oscilloscopes. Direct current, DC, examining the characteristics and applications of electric current that flows in a constant direction. Alternating current, AC, exploring the properties of electric current that periodically reverses direction, commonly used in household electricity. Power electronics, analyzing and designing electronic circuits that manage the conversion and control of electrical power. Semiconductor devices, investigating the properties and applications of semiconductor materials, including diodes and transistors. Electromagnetic fields, examining the behavior of electromagnetic fields in space, crucial for understanding wireless communication and antenna design. Telecommunication systems, studying systems that transmit information over long distances, encompassing telephone networks, internet protocols, and more. Electrical design, focusing on the process of creating electrical systems, circuits, and devices while considering safety and efficiency. Electrochemistry, exploring the relationship between electricity and chemical reactions, often applied in batteries and corrosion studies. Digital circuits, understanding the design and operation of circuits that process digital signals, crucial in computer systems and logic circuits. Mobile communication, investigating communication technologies for mobile devices, including cellular networks and wireless standards. Radar technology, exploring the principles and applications of radar systems, widely used in navigation, weather monitoring, and defense. Optical communication, studying communication through the transmission of light, essential in fiber optics and high-speed data transmission. Vacuum tubes and transistors, examining early electronic components for signal amplification and switching, and their evolution into modern transistors. Discharge and lightning, exploring phenomena related to electrical discharge and lightning, including their effects and mitigation strategies. Data communication, studying the transmission of digital data between devices, covering protocols, encoding, and error detection. Electronic design automation, understanding the use of software tools in the design and development of electronic systems and circuits. Microwave technology, investigating the principles and applications of microwave frequencies, essential in radar, satellite communication, and more. Control systems, focusing on systems that manage and regulate the behavior of other systems, crucial in automation and robotics. Robotics engineering, examining the design, construction, and operation of robots, encompassing both hardware and software aspects. Battery technology, studying the development and characteristics of batteries, crucial for portable electronics and electric vehicles. Piezoelectric devices, exploring materials that generate electrical charge in response to mechanical stress used in sensors and actuators. Real-time systems, understanding systems that must respond to input stimuli within a specific time frame, common in control and communication applications. Semiconductor manufacturing, exploring the processes involved in the production of semiconductor devices, including lithography and doping. Vacuum plasma, investigating the use of a low-pressure plasma for various applications, such as material deposition and surface treatment. Wireless power transfer, studying technologies that enable the transmission of electrical power without physical contact, often used in charging devices. Communication signal processing, analyzing techniques for manipulating signals in communication systems, including modulation and demodulation. Electronic security, focusing on methods and technologies to secure electronic systems and data from unauthorized access or attacks. Nanoelectronics, exploring electronic components and devices at the nanoscale with applications in computing and sensing. Waveform generators, understanding devices that produce electrical waveforms, crucial in testing and measuring electronic circuits. Automatic control systems, studying systems that automatically regulate processes or machines, commonly used in industrial automation. Digital signal processing, analyzing techniques for processing digital signals with applications in audio, image, and speech processing. Communication networks, exploring the architecture, protocols, and technologies that form the basis of modern communication networks, including the Internet. Digital image processing, analyzing techniques for manipulating and enhancing digital images, widely used in photography and medical imaging. Electronic gaming development, studying the design and programming of electronic games, covering both hardware and software aspects. Artificial intelligence and electronics, exploring the integration of artificial intelligence techniques in electronic systems for enhanced functionality. Computer networking, focusing on the design, implementation, and management of computer networks, including local and wide area networks. Vacuum tubes and transistors, investigating the historical development and applications of vacuum tubes and transistors in electronic systems. Waveguide components, understanding components used in guiding and directing electromagnetic waves, often employed in microwave systems. Electronic libraries and resources, exploring digital repositories and online resources related to electronics and electrical engineering. Discrete electronic components, examining individual electronic components like resistors, capacitors, and inductors used in electronic circuits. Data compression techniques, studying methods to reduce the size of digital data for efficient storage and transmission. Power system protection, understanding the measures and devices employed to protect power systems from faults and disturbances. Quantum electronics, exploring the application of quantum mechanics in the design and development of electronic devices. Superconductors, studying materials with zero electrical resistance at low temperatures used in various electronic applications. Microelectronics, analyzing the design and fabrication of extremely small electronic components and circuits. Wireless sensor networks, investigating networks of spatially distributed sensors communicating wirelessly for data collection and monitoring. Flex electronics, examining flexible electronic devices and circuits, often used in wearable technology and flexible displays. Database systems, focusing on the design, implementation, and management of electronic databases for efficient data storage and retrieval. Navigation systems, studying electronic systems used for navigation, including GPS and inertial navigation systems. Ethics in robotics engineering, exploring ethical considerations in the design and deployment of robotic systems. Solar photovoltaics, analyzing the generation of electrical power from sunlight using photovoltaic cells. Mobile robotics, studying the design and programming of robots intended for mobile operations in various environments. Electronic game development ethics, exploring ethical considerations in the creation and distribution of electronic games. Smart grid technology, studying advanced electrical grid systems that incorporate digital communication and control for improved efficiency. History of electronic engineering, investigating the historical evolution and milestones in the field of electronic engineering. Wireless sensor technologies, analyzing various technologies used in wireless sensor devices for monitoring and data collection. Quantum computing, exploring the principles and potential applications of quantum computers in electronic and computational tasks. Superconductor electronics, studying the use of superconductors in electronic circuits for achieving ultra-low resistance and improved performance. Power electronics in electric vehicles, examining the application of power electronics in the design and operation of electric vehicle systems. Electronic waste management, focusing on strategies for handling and recycling electronic waste to minimize environmental impact. Electronic system design, analyzing methodologies and tools used in the systematic design of electronic systems. Surface waves in electronics, studying the behavior and applications of surface waves in electronic circuits, including surface acoustic wave devices. Active filter design, exploring the design principles and applications of active filters in electronic circuits. Quantum electronics, investigating the use of quantum mechanics in the development of electronic devices and systems. Superconductor technology, studying the technological advancements and applications of superconductors in various electronic devices. Multimedia systems, analyzing systems that integrate different forms of media, including audio, video, and interactive content. Electrical safety, focusing on measures and practices to ensure the safe operation of electrical systems and devices. Active noise control, examining techniques used to reduce or eliminate unwanted noise through the application of electronic systems. Microelectronics fabrication, studying the processes and technologies involved in manufacturing microelectronic components and circuits. Automated control systems, analyzing systems that automatically regulate processes, often applied in industrial and manufacturing settings. Digital signal processing applications. Exploring practical applications of digital signal processing in areas such as audio processing and image analysis. Electronic entertainment systems. Studying the design and technology behind electronic entertainment systems, including audio-visual equipment and gaming consoles. Quantum computing applications. Investigating practical uses and potential applications of quantum computing in various fields. Superconductor electronics. Studying advancements in electronics utilizing superconductors for high-performance applications. Microelectronics engineering. Analyzing the engineering principles and techniques involved in microelectronics, design and fabrication. Wireless communication security. Focusing on measures and protocols to secure wireless communication systems from unauthorized access and attacks. Automated guided vehicles. Exploring the design and implementation of vehicles guided by automated electronic systems, often used in manufacturing and logistics. Electronic game development. Studying the process of creating electronic games, covering aspects of design, programming, and graphics. Ethics in electronics engineering. Investigating ethical considerations in the practice of electronics engineering, including issues of privacy and data security. Solar energy harvesting. Analyzing methods and technologies for capturing and utilizing solar energy through electronic systems. Mobile robotics applications. Examining real-world applications of mobile robotic systems, from healthcare to industrial automation. Electronic system reliability. Studying strategies and technologies to ensure the reliability and durability of electronic systems in various environments. Quantum communication. Investigating communication systems that leverage quantum mechanics for secure and efficient data transmission. Wireless local area networks, LAN. Studying the design and implementation of wireless networks within a limited geographic area, such as Wi-Fi. Optical communication networks. Analyzing networks that use optical fibers for high-speed data transmission. Common in long-distance communication. Robotics engineering ethics. Exploring ethical considerations in the design, deployment, and use of robotic systems in various industries. Electronic library resources. Examining digital repositories and online resources that cater to electronic engineering literature and information. Quantum cryptography. Investigating cryptographic techniques based on quantum mechanics principles for secure communication. Wireless LAN security. Focusing on measures and protocols to secure wireless local area networks from potential threats and unauthorized access. Optoelectronics. Studying devices that convert electrical signals to optical signals and vice versa. Essential in fiber optics and communication. Robotics engineering applications. Analyzing practical applications of robotics engineering across industries, from healthcare to manufacturing. Ethics in electronic engineering. Investigating ethical considerations specific to the practice of electronic engineering, emphasizing responsible and sustainable approaches.